This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs. Also, make sure to check out and subscribe to our YouTube original channel, UCTV Prime, available only on YouTube.
Hi, thank you for staying and attending this third session today on how sleep is related to diet, physical activity, and stress. So it's going to be very interesting in this session to really start to understand how some behavior and stress changes with regard to sleep. I'm Dr. Barbara Uriah, and I'm here at UC Berkeley. I spent the last 5 years at UCSF working with my fabulous colleague, Dr. Alyssa Epple, at Coast, and my research largely focuses on food access, and I study vulnerable populations, especially with regard to household food insecurity and neighborhoods. So I'm always really interested in all these kind of competing stressors on an individual and a family. We have 3 fabulous speakers for this session, and I'm going to just introduce the first. We have Susan Redline speaking, and she's the Peter C. Farrell Professor of Sleep Medicine at the Harvard Medical School, and she directs the programs in sleep and cardiovascular medicine and sleep medicine epidemiology at Brigham and Women's Hospital and Beth Israel Deaconess Medical Center. And what she's going to do today is really frame her talk in more of a life course setting, and most of her data that she'll be talking about and research today is focused on children, so it's going to be a interesting departure from the earlier sessions.
Well, thank you very much, and thank again the organizers and for such a really interesting and I think really provoking session. It's really an honor to also be sharing the podium with so many other great people in the field. So again, what I'm going to try to do is bring us back to sort of where it begins, which is children, although I'll talk maybe a little bit about some in utero issues, although not quite as much as I would like to today, and maybe really touch upon sort of some of the, from an epidemiologic perspective, what some of the issues that we've been discussing today mean and what might be causing them. Let's see. So in particular, I'd like to really ask you to think about what the importance of early life influences are in factors that may predispose obesity, and that is really think that risk factors really begin early in life and may operate not only on those 45-year-olds that Dr. O'Hagan told us about, but really across a lifespan. I'd like to specifically address the role of sleep deficiency. Sleep deficiency is a term my colleague Dr. Seisler coined, sort of in parallel to a vitamin deficiency, indicating that insufficient sleep from any number of reasons really causes sort of biologic, physiologic gaps. And so I'm going to talk about the role of sleep deficiency in predisposing to obesity, and in that way to chronic health conditions across your lifespan. And I'll touch on some mechanisms, and I'll talk about some of our sort of real life data on diet and sleep deprivation in teens. I'm going to identify some paradoxes that I've seen in the literature and certainly in our own data about age and gender, and maybe challenge you to think about what, if they are real, what they may be informing us about biology and mechanisms. And then I'm going to also talk a little bit about some of the childhood risk factors that might be a key link between sleep deficiency and obesity. So I'd like you to start thinking too, as we think about a lifespan approach, is there a developmentally critical period where sleep deficiency may be particularly potent as a stimulus for obesity? And again, this is a little contrasting to our very first session this morning where we were told, like, let's look at the middle-aged people. So many of you know this very old article now, but what this really shows is the importance of obesity in childhood about risk as a risk factor of becoming obese as adults. And here you see sort of different levels of obesity, where this turquoise color are individuals who are obese with a BMI greater than the 95th percentile. And this here is the percentage of children in each age group who become obese adults. And you could see that the obese child, especially, even early in childhood, but especially the obese teen, has a huge likelihood of becoming an obese adult. Now that's important for several reasons. And in particular, one of the things that we know is obesity in childhood not only predicts obesity in adulthood, but obesity in childhood predicts all kinds of other health problems in adulthood. So in this one study, for example, childhood obesity increased the likelihood of getting adult type 2 diabetes, and in fact pediatric metabolic syndrome, which was associated with obesity in children, was 11-fold more likely to result in adult diabetes. And in fact, a lot of literature now really indicates that obese children have increased rates of diseases in adulthood, not only in childhood, including asthma, coronary artery disease, diabetes, various cancers, and also that obese adolescents over the course of their lifespan have a 30 to 40% higher adult mortality rates compared to teens with median BMI levels. And this is really from data across the world, from the Netherlands, from Switzerland, and even a 50-year study from the US. And as we heard very eloquently, of course, from Dr. Van Kuder, there's been an obesity epidemic, and unfortunately, children have not been spared of this. And here's again, this data is even a little bit old, but the prevalence of obese children, both boys and girls, both from ages 6 to 11 and 12 to 19. And we could see over time, and that's really the most recent is orange, that we are, as we heard today, faced with about 20% of obese children. Now, we also heard that as we're wrestling with this obesity epidemic, we are wrestling for causes and leverage points to intervene. So obviously there are genetic factors, and in fact here's the same Botero family that we saw before, but clearly the gene pool is not really changing, although there may be epigenetic changes, which would be a very, very exciting topic to talk about another time. Clearly, there's diet and portion size and soda consumption have been alluded to, and changes in our lifestyle, opportunities for rigorous activity and sedentary behavior. However, as also been really the emphasis or the incentive for today's conference is now there's increasing attention that there's other risk factors. And we've talked a bit about sleep deprivation, and I'll talk a little bit more about that. But I also wanted to point out that another whole area is not only really restricted or insufficient amounts of sleep, but the potential misalignment of when we sleep relative to our normal circadian clock. And I don't have time to talk about this in much detail, but do want to mention that work from sort of the division that I'm at on the Brigham and Women's Hospital, Dr. Seisler and so on, and others have really shown very well that our body's peripheral and central clocks are really exquisitely synchronized. And if in fact we eat at times that our body expects us to be sleeping and vice versa, we may be at really, our body may respond with abnormal levels of inflammatory responses, blood pressure, cortisol, and in fact that may be one explanation of why shift workers are at increased risk of obesity. So now let's not only has obesity been increasing in children over time, but sleep deprivation has as well. And in fact, Dr. Seisel likes to quote that really in the last century, we've lost on average of 1 to 2 hours of sleep a night. And I think this is particularly relevant for teenagers. Those of you who are parents of teenagers probably think I'm underestimating this problem, but 33 to 40% of teens do not get the recommended hours of sleep per night, which is physiologically estimated to be 9. And in fact, some data that I'll show in just a bit later also indicates that there are vulnerable groups of the population, in particular minority children, where in fact sleep deprivation is really high. And in one of our studies, for example, we showed that 10-year-old black boys were 5 times more likely to go to bed after 11 p.m. than 10-year-old white girls. Now, we heard about some of the links between short sleep and obesity in earlier talks, but again, I like to emphasize that this data is very, very consistent in childhood. And in fact, if you compare the meta-analyses done in adult populations versus children, in general, there's stronger and more consistent associations in pediatric populations, such that overall, the overall odds is almost twofold of using a variety of studies of a child being obese based on them getting insufficient amounts of sleep. And that's usually defined on an age-specific threshold of how much sleep someone needs. And now I'd like to review a few articles that really hammer in that point a bit more, and these are some of my favorites for different reasons. Here, this one study from the United Kingdom of almost 8,000 children who were followed, really, they were enrolled in pregnancy and followed through age 7 when there was actually an overall prevalence of obesity lower than we see of 8.5%. And these are the typical risk factors I think many of you are familiar with birth weight for obesity. Birth weight, maternal smoking, parental obesity, very strong, again, genetic risk factor, TV watching, that sedentary behavior. But this group, even back when this wasn't such a hot topic, thought about asking about infant sleep. And in fact, infants at less than age 30 months who were getting less than 10.5 hours of sleep a night had an overall odds at age 7 that was about 40 of obesity of 1.45, really pretty much the same magnitude of TV watching, and these are all adjusted for the other factors in this equation. So here we have sleep in infancy being a very significant risk factor for obesity in later childhood, with an effect similar to TV watching. Now, we heard about some of the Project Viva data this morning. Elsie Taveras, who's a close colleague of mine, has also looked not only at maternal sleep, but the childhood sleep. And I'd like to again point out this lovely work, because this was on almost 2,000 children. And it was a population-based sample where, again, the children were enrolled in utero. And what she showed here is a progressive increase in the prevalence of overweight, really associated with short sleep in infancy. And you could see, in fact, when infants were getting less than 11 hours of sleep, they were the overall prevalence of overweight was about 14%, whereas when they were getting 13 or more hours of sleep, it was about 6%. But what was also, and in fact, she estimated and adjusted analyses that at age 3, overweight was twofold more likely in infants that were getting less than 12 hours of sleep per night. She also did something very interesting. And she and others have, as I noted, have been very interested in TV watching as a risk factor. And in this analysis, they actually tested for the synergy or potential interaction between TV watching and shorter sleep. And what you could see here is this in dark blue are children who are actually watching television for more than 2 hours a day, and the lighter blue less than 2 hours. And these are the children who are getting less than 12 hours of sleep. And you could see that the overall rate of overweight is much higher in children who both get less sleep and watch more television. Now, this study is another study that from Japan, and I like this study not only because it was almost, again, about 8,000 children, but also because it identifies another factor that I like to emphasize. So here's a cross-sectional study looking at obesity and questionnaire-based sleep deprivation with more than 10 hours a night here, going up to less than 8 hours. And this analysis was stratified by gender, which is another theme I'll emphasize. And what you can see here is that amongst the boys, there is a very strong progressive increase in the overall adjusted odds of obesity as sleep duration decreases from greater than 10 to less than 8, such that these boys getting less than 8 hours of sleep were 5.5 times at increased odds of being obese. Now, you also see a significant association in the girls, but you can see it's much weaker. So the overall odds ratio is 2.1 here versus 5.5. And this is a theme I'll reiterate in the next few slides as well. So in the Cleveland Children's Sleep and Health Study, which was a cohort I directed for a number of years, we also looked at the association of sleep duration and overweight and obesity in a population-based sample in urban Cleveland. And again, we found, and in fact, when we did our analyses and we looked at children ages 8 to 11, we estimated that each hour of decreased sleep duration was associated with an increased odds of overweight, but it differed dramatically by sex again, such that in boys, the overall increased odds was about 70% and girls 10%. Or if in fact you you looked at the overall odds ratio of being overweight or not, you could see it was about 1.6 in boys and really not significant in girls. We then also, in that same sample, which we studied longitudinally, we then actually looked at age specificity of these relationships, first cross-sectionally, and then in the next couple of slides, longitudinally. So let me walk you through this. So again, this here now is based on just 312 children that we had comparable data at on 3 different exams. And these are exams when their ages 8 to 11, 13 to 16, and 15 to 19. So these here are 3 different exams at different ages in the same cohort. And the y-axis is the overall effect relating each unit change in BMI score per hour of sleep for boys and for girls. And what it shows that in boys here in age 8 to 11, each 1 hour decrease in sleep duration was associated actually with an adjusted 0.31 decrease in BMI Z-score. And that actually still was significant when you looked at these relationships cross-sectionally when the boys were 13 to 16, although the association was a little bit less, and then it was non-significant when they were teens. And you see a much, much weaker association in girls. However, these were still cross-sectional, and then what we did, though, was ask the question did sleep duration at ages 8 to 11 then predict subsequent BMI, first at ages 13 to 16 and then 16 to 19? And this is going to be a little complicated, but let me point this out. These are the results of longitudinal models, and there's going to be a series of models that I will show you. And this first one, and first I'm just going to show you the boys right now. And this model here is predicting BMI Z-score when the boys were 12 to 15 years of age. And what it shows is even after adjusting for socioeconomic status, birth weight, race, and age, that again, there's a significant association between sleep duration and BMI Z-score at the subsequent age. So again, sleep duration at ages 8 to 11 had a significant negative effect, a significant effect on BMI at the later age. And then when we looked at, in this model, sleep duration again at ages 8 to 11, but predicting BMI a little later in childhood, actually on the cusp of adulthood, when the boys were 16 to 19, we see a slightly attenuated, but still a significant association with each hour increase in sleep duration, predicting an increase in BMI by 0.3, BMI Z-score of 0.3, quite a significant effect. But here's the rub. If, in fact, we additionally adjust for BMI Z-score at ages 8 to 11, when we're actually also looking at sleep duration, we find out that obesity at age 8 to 11 is the strongest risk factor for obesity at each of the subsequent exams. And in fact, the association between sleep duration and obesity became really non-significant. So the way we've interpreted this out is, again, the importance of early life influences. When the children were young, having short sleep made them cross-sectionally at that point more obese. And being more obese at that time actually put them on a trajectory to be more obese later in life. Now let me just switch gears a little bit. We'll come back to that thought in a while, but then again briefly talk about the mechanisms that may be relating to why sleep duration may influence obesity. And these were referred to in all the prior talks. I'll go very quickly. But again, there are many pathways by which sleep deprivation may actually increase cortical function. Also, not only about executive functioning, but it's been postulated sleep deprivation may cause behavioral problems, impulsivity, making bad food choices, sleep deprivation through some of the hormonal things Dr. Van Coder talked about may cause increased hunger, again, and poor food choices. There may be more opportunities to eat, all leading to increased energy consumption. There may be direct metabolic effects, as well as fatigue and decreased energy and obesity. So there's many pathways, all of which probably are operative at different times. So we tried to look at one of the first areas, and that related to behavior. So again, in this study of about here it was 819 children, where we not only had daily sleep diary information to look at sleep duration, but we also did extensive behavioral testing. These are the childhood behavioral checklist, the CANA's parental rating scale, the parental stress index, and we looked at a whole lot of factors, including internalizing, externalizing behavior. So unadjusted, we actually, again, for each decrease in 1 hour of sleep, we have an increased odds of overweight of 1.47. Then we adjusted for all these other factors, and there is no change. So behavior in our sample, even measured in a very structured type environment, did not explain the association between short sleep and obesity. Now, we've heard about the hormone and appetite hypothesis eloquently from Dr. Van Coder, but let me just sort of refer to some work from the Wisconsin sleep cohort, because this takes it away from the experimental setting to the population-based setting. And here was actually just a plot in the Wisconsin cohort of adjusted levels of leptin on this axis and adjusted levels of ghrelin. And again, you see that with decreasing sleep duration in a population not manipulated, you get the expected differences with decrease in leptin and increase in ghrelin that Dr. Van Coder would have predicted from her experimental models. Based on that and other work out of the University of Chicago, you would expect people who are sleep deprived then to have different dietary patterns. So we actually were interested in testing this really in a real-world setting, again in the same cohort that I talked to you about before, but this time we actually focused in our teens who are ages 16 to 19, all of which not only had questionnaire data on sleep, but we had 1 week actigraphy data on sleep, we had accelerometry data on physical activity, and we had 2 to 3 24-hour food recalls in order to characterize their dietary consumption. And we used those dietary recalls at one level to look at macronutrient consumption and see if, in fact, the proportion of calories children ate in terms of carbohydrates, fats, and proteins differed in that 1 week according to what their actigraphs were telling us they slept during that 1 week. Completely non-controlled situation. Children were in their own homes and school and work and God knows what else, but we were collecting this to really get an ecologically valid sort of insight into what might be happening with teens. And what we showed here was this is sleep duration on this axis, and this is the percent of daily calories and fat. And you can see as sleep duration decreases, this is the estimated fit of a line, the percentage of calories these children were eating related to fat progressively increase, such that, in contrast, the percentage of carbohydrates. Now this category also includes good carbs, the complex carbs, and so forth, because there's just 3 categories. It's protein, carbs, and fats. So there was no change in proteins. So what happened was increase in fats was associated with a decrease in carbs. And our estimates showed, after adjusting for many factors, that 1 hour decrease in sleep that these children had was associated with a 0.8% higher daily fat and a 1.2% lower carbs. Now, what that really means, in a different way of looking at this, is that the daily fat consumption for children sleeping less than 8 hours per night was 2.2% greater per day. Now, add that up cumulatively, and over the year, that high energy food could really contribute to quite a bit of weight gain. The other thing we did in the study is that we really looked, because we had detailed 24-hour food diaries when these children reported to be eating. And in fact, the short sleepers, we actually thought maybe they were eating late at night, 1, 2 in the morning, but in fact, they were eating 5 a.m. to 7 a.m. And in fact, the other thing that they were doing, similar to one of the articles, the Neflover article that Dr. Vankuda talked about, they were also consuming a greater proportion of their daily calories, not in the early, also with snacks as well as early in morning. Such the short sleepers were 2-fold more likely to have higher caloric snacks, again, and tending to eat more of their food early in the morning. The reason I emphasize this is that those things that I was saying a little earlier about circadian misalignment. Teens are naturally phase shifted, and a lot of their hormones really are synchronized, so that actually many of them adjust their body, and their hormone levels may be waking up 10, 11 in the morning, and here they may be eating at a time that's misaligned according to their adolescent cycle. It's just speculation. Now, the other thing that was interesting is, in contrast to a lot of the other work that shows the association between sleep deprivation and obesity is stronger in boys than in girls, these relationships were stronger in girls. And I don't know if it's because girls gave us more accurate food recall histories, and boys tended to forget about the 20-ounce double Mac things, and the girls were more conscious about that, or if in fact maybe emotional eating and the response to sleep deprivation may differ in boys and girls. Now I'd like to just show now a study even a little bit later in childhood. This is in high school, and this was actually a suburban high school in the greater Cleveland area, done by actually a high school student who won actually a very nice prize for the work and now is finishing medical school. And here she showed, again, not unsurprisingly, this is the overall prevalence, of sleep duration in these teens. And you could see that actually a good 20% of teens here in high school, and this was a middle class school, was getting less than 6 hours of sleep. And what was interesting was, in this particular group, that those teens getting less than 5 hours of sleep per night were 5-fold more likely to be overweight after adjusting for other factors. But I'm showing you this now because we also wanted to see if their junk food intake differed, their physical activity. And in this survey, which was probably not the most precise, it was a high school survey done by a high school student, we didn't detect that. But what we did detect, and I like to put that out as a hypothesis, is that in fact the short sleepers, which we are not that surprised about, were consuming much more caffeine than the other children, and in fact high caffeine intake was associated with increased obesity. And there are many more nutrition-oriented people in the audience than me, but I actually do wonder what's the role of caffeine in appetite and potentially being a mediator between sleep deprivation and obesity. So Insufficient sleep, let me now just do an interim summary. About 20% of teens get less than 6 hours of sleep per night. Short sleep, as I mentioned, is about 5-fold more likely in minorities. In particular, we're found in black boys than in other groups. And I also like to point out that, that short sleep, even throughout infancy, is more likely to occur in children of low socioeconomic status and children of racial minorities. So in a study published a few years ago showed that black children now 2 to 8 years of age, even after considering their napping, sleep on average 20 minutes less than white children. This is again some of Elsie Taveras' data from Project Viva, and again, remember this is at 1,900 families that she studied, and she again looked at the prevalence of short sleep in infancy, here defined at less than 12 hours, and you could see that both black children and Hispanic children were about twice as likely to have short sleep compared to the whites in the sample. And furthermore, she looked at all these risk factors for obesity in childhood. She looked at gestational weight gain, large for gestational age, breastfeeding, television watching, TV in the bedroom, and right here is infant sleep duration of less than 12 hours. And you could see it's actually one of the strongest risk factors of all the candidate risk factors. And this line, you see it for the blacks, and here you see it for the Hispanics. So in fact, we have a very high prevalence of short sleep in infancy emerging in minorities in particular very early in life, and also very strongly associated with obesity. So that really brings me to basically a portion of the talk where I'd like to now just sort of speculate that as we think about a life course approach, we have to think about subgroups of the population that may be under different stresses very early in life. And in fact, it does seem that minority children are more likely to be at risk for obesity and all those chronic diseases, but they are also more likely to be at risk for short sleep. Why might that be? That may be due to cultural factors with co-sleeping. We also looked at parenting styles, and having a sort of a permissive or strict parenting style can significantly shape the sleep of all members of the household, including the children. Clearly, we're interested in the adverse physical environments, and in fact, many of these children live in environments that are noisy, have adverse light exposures. Many children don't have their own bedroom. Also, children from many low-income areas may be exposed to environmental tobacco smoke and pollution, and in a couple of slides I'll show in a minute, that itself may predispose to both poor quality sleep as well as the disorder sleep apnea in children. There also are perinatal factors that may preferentially affect children of low socioeconomic status and minorities, and it's been shown that low birth weight actually may adversely affect the development of the brain and the sleep and circadian centers, and that's also been supported by some epidemiologic work from Europe. And finally, as I alluded to, is that sleep may be or the environment may actually really have significant epigenetic factors that may shape both brain development influencing sleep as well as other pathways on the way to diabetes and obesity. And finally, there's also the issues of children who come from households where parents are working multiple jobs, are stressed themselves with home chaos and shift work impairing their sleep. So children from some of these backgrounds have multiple biological, environmental, and social factors that may be contributing to their poor sleep and being an additional whammy, increasing their risk factor for obesity and other life problems. So, and this here is actually some recent data from a colleague of mine, Dr. Storfer-Iser, who looked at something very interesting. I hope it doesn't disturb any of your working mothers in the audience. But she actually did a survey of about 240 women, and she compared mothers who were employed to homemakers and asked about their child's sleep. And these were children, toddlers, early age. And she showed that, in fact, perhaps not unsurprising, that mothers mothers who were employed were actually their kids got up significantly earlier, and in total, those, and that was especially true in the weeknight, such that they, on average, got almost 40 minutes less sleep per night. Now, I bring this up right after talking about racial disparities because, in fact, many families, many parents in low-income families have multiple jobs. So this was actually a study from really a middle-class kind of setting, but I think I'm putting it out there to also imagine the other stresses working mothers and fathers may be on that may involuntarily influence their children's sleep. I also wanted to point out that the children of the mothers were not only at increased odds of sleeping less, but they were also less likely, and that's shown here, to really wake up on their own. Only about half the number of children waking up on their own. So they're really being, come on, wake up, I have to go to work. Okay, so as I think Dr. Grandner will really embellish later as he goes into more adult data, I just want to emphasize that a lot of these issues from a lifespan are important in children too, and want to leave you with the thought that minority children seem to be disproportionately affected by sleep problems. There's likely intergenerational effects. There's probably multiple environmental and biological effects with both gene-environmental interactions, epigenetic factors, and having these exposures early in life sets these children up for significant cumulative burden of potential disease and risk factors. And in fact, that may in fact be one of the explanations of why we see obesity, hypertension, cardiovascular disease, and diabetes in so many of our low-income families. Also, I'd like to leave you from a life course perspective with this other model. And here again summarizes that, in fact, insufficient sleep often manifests in infancy and early childhood. And that may be due to many socio-environmental factors, family, neighborhood, and parents' occupational factors, clearly maybe some perinatal, prenatal, and genetic factors. And if really operative early in life, this insufficient sleep appears to be a potent risk factor for obesity very early in childhood. And I don't need to tell anyone, and I've showed some data, that it's really obesity early in childhood that drives obesity in adolescence, which drives obesity in adulthood, leading to metabolic syndrome, cardiovascular disease, and so forth. So in summary, shorter sleep times in infants and young children may be contributing to the rise in obesity. These effects may exceed, in fact, many traditional risk factors, including soda consumption and TV watching. The mechanisms aren't clear. I think our other speakers talk much more eloquently than I, but clearly there seems to be differences in appetite, dietary choices, maybe both due to cerebral mechanisms and the adipokines that get released. There also may be factors related to when we eat or misaligned eating, differences in energy expenditure, which our next speaker will talk about, and maybe metabolism. I also want to leave you with the notion that there may be potential developmental windows of susceptibility, and we need to focus this problem in individuals early in life. There's also very interesting gender differences. There could be social, and also there may be sex hormonal effects that may modulate some of these relationships. Poor ethnic minorities are particularly high risk, and there's multiple environmental and social risk factors that may explain this. But the good news is that maybe there's new potential targets for both improving sleep and thus health, and thus maybe improve health disparities. So rather than fat for life, I think what we really need to do is start really having prescriptions for healthy, active living. This is something for the American Academy of Pediatrics, the 0, 1, 2, 5 fruits, and so forth. But I like to say that we need a 9 for children. That is, get enough sleep every night to feel awake in the morning. And that's a part of the prescription for health. Well, thank you very much.